Now joining us on the stage, we have a panel discussion, humans and robots, colleagues of the future. So why don't we go ahead and take the stage, Barry, our moderator, Brady, Bernardine, and Chris as well.
Thank you, Jenny. Thank you, Pittsburgh Robotics Network. Thank you, panelists. And thank you, wonderful people in the audience who got up bright and early to join us and talk about the future of robotics. I'm going to quickly introduce myself and ask the panelists to do the same. We'll go through it, name, years in the industry, job title, company, and just a little bit about what your company is bringing to the world. So I'm Barry Rabkin. I've been in robotics for about 12 years. I have a little bit different background. I was actually a psychology major, and I really come at it from the angle of putting humans in the center and how can technology serve people. That's the mission. I work as the director of marketing at near-Earth Autonomy, which makes basically AI pilot systems for aircraft, filling the role of a human pilot, and able to find hazards, respond to them, keep the vehicle and the cargo safe. So with that, I'm going to turn it over to Brady.
Hey, good morning, everybody. My name is Brady Sheehan. I currently work at Neya Systems. I'm on the advanced projects team. I've been working there for about 2 years. I've been in AI and robotics for almost 10 years. At Neya Systems, we build off-road navigation autonomy solutions. And so off-road navigation is often dangerous and expensive and difficult. Our systems automate a wide variety of these vehicles and platforms to help make off-road navigation more accessible to people without having to be in danger.
Hi, I'm Chris Dunkers. I'm head of software at Thoro.ai. I've been in the industry almost 10 years as well. At Thoro, we're building autonomous systems for manufacturing, logistics, and the cleaning space, trying to automate some of the more menial tasks, more easier tasks there.
Hi, I'm Bernardine. I'm sort of new to industry, but I've been in robotics for over 3 decades now. That's a long time. I work at Stack AV. I'm on the product team right now. But before that, I was a professor at Carnegie Mellon University. So Martial, who spoke earlier, was one of the people who actually introduced me to robotics, and I'm very grateful for that. While at Carnegie Mellon, I did a lot of different things, ranging from human-robot teams, robot team coordination, to technology in the developing world and in different underserved communities around the world. At Stack AV, we are working to revolutionize transportation, starting with fully autonomous trucks that are going to deliver goods in long-haul trucking. So happy to be here and excited to talk about all the topics.
All right, perfect. So just to echo some of the early speakers, we've seen unbelievable progress in robotics recently, right? This industry has been around for a little while, but it's just been moving by leaps and bounds. Pittsburgh is a big part of that. We deserve our credit, but it's not just Pittsburgh. So can you share a little bit about what forces or at work, what changes have happened in the last decade to help accelerate the progress of robotics and AI and move it forward? It's open to anyone.
I can start, sure. I guess I've been around long enough. I remember when, so I started out actually in physics, and I was a physics computer science double major with a minor in women's studies. So I did everything. But it really fascinated me, the concept of robotics and being able to apply both my physics and computer science knowledge and really take that out to the world. So that's why I came to Carnegie Mellon. I got my PhD there, and then I stayed on as a professor. And I remember I was in field robotics, and I was taking robotics and going out into the world, and how impossible everybody thought that was at the time. And then there was the DARPA Grand Challenge. Didn't do so great the first year, but there was this fire that was lit, and it just took off from there. People believed that it was possible. There was a lot of momentum behind it, and with that came a lot of new technologies, a lot of new enthusiasts, a lot of new younger generation people who wanted to get robotics out there. And then came, the industry partners, the investments, and also, of course, the legal and policy sides and all of that. And we see a similar revolution, I think, with AI now, and everything becomes it's sort of lifted up to a different level, and there are new things we can do, and with that, there's always this balance of, do we build fast, do we build carefully, and how do you find that balance so that we're building things that are safe, that are good for the world, and responsibly. But it's super exciting at the same time. Lots of things that are at our fingertips, things that are changing very rapidly. Every day is a new and exciting day. So.
Yeah, I think that was a great answer. To piggyback off of what Bernardine said, I think there's three major factors driving the development of AI and robotics in the industry right now. I would say that's data availability, compute availability, and data availability, compute availability, and competition. So basically, as more data becomes available, because we've created more synthetic data sets and real data sets that have been collected over time, we have more opportunities to train models and test our robotic applications on those data sets. Additionally, as we develop better compute, it's more accessible to people at a lower cost, we're able to integrate a lot of these solutions on advanced computers that allow us to deploy these applications in real world use cases. And lastly, because of these data sets and these computes, we have more competition that enables us to actually compete against one another and develop and innovate on these solutions that allow us to build more robust AI applications and robotics applications.
We hear about sort of the 3Ds within robotics, right? Dull jobs, dirty jobs, dangerous jobs. These are some of the prime candidates to bring robotics and AI solutions. Can you maybe expand on that? And this is, again, open to anyone. Where are the use cases where people are seeing the most value bringing robotics to it? And where maybe some areas that it's not as good a fit?
So I can kind of talk a little bit. Our robots are going out into the world and are helping facilitate movement of goods in warehouses, in manufacturing, cleaning floors out in the world. And I would call those very dull tasks. A lot of the movement tasks are extremely dull. The way we like to see our robots are as another tool in an operator's tool belt, right? Now, instead of the operator being the one to clean the floor, they can be the one to clean the bathroom, the part that's more difficult, getting into the nooks and crannies, clean the windows. In your manufacturing space, we're seeing the travel of pallets go 500 meters in one direction. It takes 5-10 minutes to get across. The person should be doing the difficult tasks of stabbing the pallets, organizing them at one end and the other end, and all that menial, dull work of going back and forth should be automated. And that's kind of where our robots are really shining.
One way I've heard it put is, you want to use robotics to do what they do best, the most repetitive, most kind of soul-crushing tasks, to free humans up to do what we do best, which is more creativity, more strategy, more vision, kind of higher level thinking. And I think that's a theme that you're going to hear again and again from this panel. At Thoro, maybe just to build on that, Chris, how are roles changing? It sounds like some of it is maybe now they're freed up to do some different work. Are there jobs that involve managing the systems from your technology, maintaining the systems that are now sort of being created?
Yeah, absolutely. I think when we look at deploying robots, we try to have a key point who's responsible for the robots. Each robot needs sensors cleaned, whether that's the pallet jack or our scrubber. When you're looking at our scrubber, you need to clean the water tanks, fill the water tanks, and then you can now be responsible for more than one robot. So you're the fleet manager. So instead of coming in and being the person driving a single machine, you're now the person managing these fleet of robots, whether that's in the warehousing or in cleaning. You're managing these robots. It's your responsibility to keep them up and running. So your job's changing because now you need to know, how does a robot work? What are the things to make the robot successful? And how can I use the robot to help me with my job? So again, your robot's we try to think of it more as a tool for these people than something that's coming in to replace anything they're doing because there's plenty of work. And so they're just now, setting these robots off, and then they're able to do something different.
Yeah, if I can build on that, I also think that in some ways we are at a stage where we're starting to graduate from the 3Ds. And so if we talk about the future of, a future where humans and robots are truly colleagues, I think one step towards that is that robots are now making humans more capable of doing things too. So, whether it's through tooling or exoskeletons or, you swallow a robot that can go through your body and send out images or whatever it is. And then eventually, I think there will be a time when humans and robots are doing what they are best at doing, but it might not be sort of a blanket statement. It might be within that context, or that particular organization or that field, there is a division of labor, but there's just a lot more connectivity and sort of working together in a symbiosis, which I think is really interesting.
I think you touched on something really interesting, Bernardine, which is the kind of augmentation, as with the Iron Man suit, right? That lets you do, or Iron Woman, lets you do things that you couldn't do on your own. And I think most of us have a pretty easy time coming to grips with the idea like, hey, I can't talk to someone on the other side of the world by myself, but I pick up a phone and I can, right? I can't go 60 miles an hour down the highway on foot, but I get in a car and I can. Why do you think it's a little bit harder for some people to kind of wrap their minds around the idea, like general population idea of you use these tools and you can do things that you can't do on your own, but there's, for some, a little bit of hesitation when it comes to AI and robotics. Is it just that it's new, or is there something fundamentally different about it?
Yeah, I think it's a combination of things. There's the aspect of it where it's unfamiliar, which I think worries people and kind of makes them nervous, but then there's also the understanding and education component. So a lot of folks aren't familiar with exactly how these systems work and what they're capable of. And usually in our experience in Neya systems, once we've trained these robotics operators to learn how the system works, what it excels at, what it doesn't excel at, they're usually much more familiar and comfortable with it, and that allows them to open up and feel acceptable and understanding of the robot and use it in the real world. And I think that's a big part of it, just that lack of understanding and familiarity, and as they gain that, it really opens things up.
Can I build on that
Please,
really quickly? I actually think it's really healthy, and in fact, that's how we build better systems, is having people who are a little afraid, other people who are going to dive right in, and that combination and that whole spectrum is what helps us to make better futures for all of us, right? So the people who are questioning everything and saying, hey, hold on, they make us stop and think as designers of this technology, okay, what are we not considering right now? And then the people who kind of jump ahead and like, oh, I'm all in, usually the younger generation is, much quicker to adopt things, and that's not a bad thing. I think that's also helps us kind of catch that momentum, and together. So the thing is, if we build things in isolation, that's always bad, in my opinion. That does not lead to good products. But if we work together and truly listen to each other, and in many ways participate in that design process, then the outcome of it is really going to be something that serves all of us in a better way.
I know you use CDL drivers at Stack. What kinds of, how is that role different than being maybe a typical CDL driver? What kind of skills do you look for, or mindset do you look for from the people you work with?
Absolutely, that's a great question. So at Stack, we actually have quite a range. Some of the drivers love technology and others really don't. And one of the things I do is build or design the interface that sits in the truck and gives them the information about, hey, what's the truck thinking about? So that they can decide when is it safe to take over. But their job is actually much bigger than that. I mean, I know nothing about driving a truck. I'm terrible at driving a truck. But they are amazing at it.
You just do easy stuff like
exactly,
building
I just
robots.
do easy stuff. But it's amazing to watch them maneuver these huge trucks into really tight corners around different bends. They understand not only sort of the legality of what are the laws of driving, but also the very practical side of, I'm driving on a street that has all this crazy stuff that can happen. and all these people are driving as well. So how do I make the best decisions? And that's something we learn from them and incorporate into how we design the autonomous drivers.
An interesting difference between sort of the self-driving world and the self-flying world is in self-driving, you have a million different things to worry about, right? And you need to be able to predict all these different vehicles and pedestrians all simultaneously. Usually in aircraft, there's really very little to worry about. That you don't have that level of traffic and congestion, but if something goes wrong, even for a split second, the stakes are really high. And we're dealing with things where our partners are sweating the system's weight down to the fraction of a gram, and hopefully with Mack trucks, they're a little more forgiving on weight and energy requirements. So it's just interesting seeing the two worlds.
Yeah, I mean, definitely potentially different scales, but a truck can cause a lot of damage too on highway speeds going, yeah.
But not one piloted with a stack AV system,
That's right.
Yeah. Brady, can you share with us some of the use cases for the products that that Neya offers, and some of the benefits that customers are seeing from them?
Yeah, absolutely. One of the cool things we worked on recently, actually this past summer, was automating a skid steer vehicle, so a CAT 299 D3, for the purposes of doing some construction operations for the military. We actually took that product that we developed to the military base and trained about half a dozen soldiers to operate it. Then they used it for a week on their own to complete some exercises that they had going on. It was really cool to see them do that because we were able to educate them on the robot, what it can do, what it can't do, and then watch them use it in real time to accomplish their goals, all while removing them from the cab and keeping them out of danger. Because normally they would be in the cab operating this equipment, behind enemy lines or at risk of enemy attack, but we've allowed them to remove themselves from that danger and use the robot in place of them so that they can be safe and still accomplish their goals and their mission, which I think is really cool, and we're seeing a lot of value for our customers in doing that.
So I think for everyone in this panel, everyone in this room, we care about the future, we care about our careers, we want to be successful. How do we best use these technologies and technologies like these, adopt them, whether it's your specific companies or just thinking about robotics, AI, automation, to make sure that we are putting on our suit, we are using this to its full benefit and impact without kind of overusing it to a point that maybe the technology isn't ready for?
I think one of the key things is I think we've touched upon it already, is really understanding the limitations of the system. So making sure that when you're deploying or you're talking with everyone is making sure they understand, like, what are the limitations of the system, and ahead of time people could understand what are the limitations of LiDARs, of cameras, of some of the sensor types that are being used in these systems, and kind of understand, oh, maybe this isn't the right use case. Because I think, like, to that point, is people get frustrated when they use it in ways it shouldn't be used because it's not there, and then that frustration leads to, hey, I don't want to use this tool anymore, and then all of a sudden you have robots being returned and not being used and sitting in the corner collecting dust. And so I think really there's a lot of material that needs to be generated and things to help deploy and really teach people about that limitation of the system as a whole and as of each individual sensor.
So if we think of it like Goldilocks, right? You want to be not too optimistic on the capabilities, not too pessimistic, but just right. The challenge is just right is changing day by day, right? These technologies are getting better over time, and some of the foundational systems that help us build these technologies are getting better over time. So I'm curious, have any of you found ways that help you kind of increase your pace of education as you're going through this? Maybe it's learning techniques, maybe it's newsletters, maybe it's actually learning tools or AI tools, but how do you keep pace as things continue to accelerate to make sure that you're walking that tightrope? Or that six-lane highway, if that's a better analogy.
I'm sorry, I didn't hear the last thing you said.
So instead of a tightrope, it can be a highway.
Oh,
yeah.
Yeah, that's tough. I think that's that's multiple levels of, you can, as a company, you can make that choice to provide certain amount, or it doesn't need to be a company, it could be a school or whatever, organization. As an organization, you want to invest in your employees or your members' ability to learn, so you want to give them opportunities to learn and grow. I think a big part of it is also creating a good culture within that organization where you have safety at the core. So you want to make it very clear that if anyone is concerned at all about safety, that they have the right and the means to speak up. And you always address that meaningfully and not just say, oh, yeah, that's fine, we got it covered, or something like that. But also curiosity is encouraged. And so like I spend lots of times, for example, riding in our trucks, and the drivers ask me all kinds of questions, and it's like a great exchange because I can explain the tech to them, and they can explain a lot of things that's happening on the roads. And sometimes it's an entirely off topic of philosophy or whatever that then comes back to, hey, how do you think AI is going to impact this or whatever? And those are great conversations. And just having that kind of culture is really important. And then the other thing is, outreach. So I have two kids, one in middle school, one in high school. I try really hard to make sure I stay engaged with the schools. I know a lot of people at Stack and all kinds of organizations do a lot of outreach. Go talk to the kids, go help teachers redesign courses. I've done that. Whatever it is that takes to keep all of us moving together ahead.
So I have 3 young kids, 6 through 10. What skills, what mindsets do you think are going to be much more valuable, maybe 10 years out from now, versus what was more valuable 10 years back?
10 years, that's a long time.
Well, yeah, but what are you
but no,
encouraging
you're right.
your kids to pursue?
Honestly, I think the most important skill is critical thinking. Okay, like I cannot emphasize that enough. I think you should learn to question everything and come to informed answers. I think informed answers is going to be the tougher challenge because the truth is getting obscured a lot. Like what we relied on, say a video evidence or something like that, is totally manipulated now. So that's a conversation I have with my kids all the time. It's like, how do you know this is true? What's an original source? Like, go figure that out. Get multiple sources before you decide something is true. But then think for yourself too, right? That's really important. Ask questions, stay vigilant about this because I think that's one of the biggest challenges.
So when you're talking about doing ride-alongs with Stack, I recently heard a podcast interview with the chief product officer of Uber. And he was saying about a third of his time is spent making deliveries, right? To really get to know what are the pain points and what is where the opportunities for growth. Another thing he said was that you need to know on a visceral firsthand basis where it hurts, right? And what that experience is like. And something that AI isn't great at is reading between the lines. He said if you just give it a mountain of customer research or kind of direct transcript, it's going to take out of that what was actually said. It will not read between the lines and kind of understand what was actually meant, which can be two very, very different things. So do you feel like both interpretation, communication, leadership, creativity, those are some of the skills that are actually going to increase in value versus today? And that's open for everybody.
Yeah, so I think it's a great question, and I would say yes. So my background actually in undergrad was in liberal arts. So I went to Duquesne University, I got my degrees there. And so I spent a lot of time taking philosophy classes, history classes, communications classes, and I found those to be extremely valuable in my career as an engineer. I think a lot of the engineering courses are really great, but I don't know that they always emphasize critical thinking as much as I think they should, because often they sort of prescribe certain ways that you should come to your solutions. They give you a set of tools, they say, hey, use these tools to come to an answer and show your work, and they expect your work to maybe look a certain way. But when you take classes like philosophy and writing, you don't have those guardrails necessarily. It's kind of open-ended in more ways, and that allows you to actually really apply critical thinking and to learn how to use this wider set of tools that you have that I think are really valuable and help a lot in engineering.
I think there's a really important difference between knowing how to solve the problem and knowing which problems are worth solving, right?
Yeah, and to kind of piggyback off that a little bit, I think like a healthy dose of curiosity. Like, I think in school you are prescribed so much that you kind of sometimes lose that curiosity. And kind of when you're in industry and kind of looking at your robots, of thinking about like whether it's a technical problem or how is this robot going to be used, how is this robot going to be interacted. We do a lot on our UI to try to make it seamless, easy to use, and all that kind of stuff. And just having that curiosity to go, look at someone using that UI and understanding what they might want to see or even hear at the right time makes a huge difference in how a product's being used. So.
I think the other thing to remember, to build on the point of communication and curiosity, is that more and more these solutions that truly are impacting the world are not things one person builds. Right? You have to work in a team. It's often a globally distributed team. You have to take into account a variety of stakeholders, and so those communication skills are really essential. And again, don't be limited to a single language, in my opinion. I mean, language shapes how we think in many ways, so learn as many as you can. Be open to that people are going to think differently, they're going to work differently, and take all of that into account when you're building systems of the future.
I know we could talk about this all day, but I want to be respectful for the next speakers. Let's give a hand, please, for our panelists for sharing their insights with us. Thank you, Pittsburgh Robotics Network, and thank you all for joining us. And I'll just close on the sea of change is, we're in it, right? Just like when we transition to computers or the internet or cloud, and some people are sort of shaking their hand at the coming wave. Some people are trying to bury their head in the sand, and I'm really encouraged by all the people here who are grabbing their surfboard and riding that wave as we build a better future. So thank you very much.
Thanks, Barry.
Thank you.
Thank you.